All right, welcome to the second review. This is going to be going over area and arc length of a circle. Let's review the formulas. In a circle, the area of a circle is pi r squared. So when I want to know the area of a sector, that sector is going to be measured in degrees. So you'll have some degree over 360. And this symbol here, theta, is just a Greek symbol. It stands for degree or radian measure. So in this case, it's going to be degree because it's out of 360. And then we're going to multiply that by pi r squared because the area of a circle is pi r squared. You also have the length of an arc in degrees, and that's going to be the degree over 360 again, times the circumference. And remember, the circumference is 2 pi r. So this is area of a circle, and 2 pi r is circumference. Let me kind of jot that down, circumference. And then we also have the arc length in radian measure. So we usually say S equals the radius times the radian measure, r theta. And so this is going to be radian, not degree. So you have a couple questions that deal with radians. And then S still stands for length, but I think they want to distinguish it between length of an arc and degree. So they usually use the S symbol. R still is the radius. So the common thread is they all have a radius, they all have an angle, but this one has radian angle, this one has a degree angle. And we're not going to worry about how to convert between radians and degrees right now. That's in a later unit. So let's work on getting started. Our first question, you click on the picture, you can see it a little bigger. We have a circle that has a shaded portion, but the question wants to know, and again, try this on your own before you do it. So pause the video and then check the answer. What is the area of the unshaded portion? Well, we're in luck because the unshaded portion is the one that has the degree, okay? So we already have our degree. We have the radius, that's this length here from the center to the edge. So r is equal to 7, and then our degree, that's equal to 50. So if we're working that out, it's going to be the degree, which is 50, over 360, multiplied by pi r squared. So 50 over 360 times pi r squared. This is just a numeric entry, so you can put that into here. Let's see what we get. I won't need any graphs for this, so we can just focus on the calculator. So 50 divided by 360, and then right arrow, and you can do pi for pi. And don't use 3.14, use pi, use the pi symbol, and then you can just type in the 7 for the radius, and then square just the radius. Don't square the pi, so make sure the 7's in parentheses, and you're going to get 21.38 square units. So this should be a 7. So you get 21.38, and just put that answer in. You don't have to worry about putting the unit in, just put 21.38 as the number. Oh, round these all to 2 decimal places, so that's why I went to 3/8. Next question. All right, in this question here, again, you can make this bigger by clicking on it. In the semicircle below, what is the area of the blue shaded region round to 2 decimal places? And the blue region here happens to be in the middle. That is an unknown degree. But fortunately for us, we have in a semicircle 180 degrees. That's half of a circle. So 180 degrees from there all the way around until there, which means that this missing angle, if I subtract the two numbers here from 180, I will get what that number is. So I'm going to do 180 minus 50 minus 35 and see what I get. 180 minus 50 is 130 minus 35. 130 minus 35 should be 130 minus 35 should be 95. 130 minus 35 is 95 degrees. So now we have our degree measure. And this 22 represents the diameter because that's from edge to edge. If you think about this circle being extended, the radius would be only half of that. So the radius is going to be half of a 22, which is 11. So your radius is 11. And now we have the same formula as we had before. It's the degree over 360 times pi r squared. So we have 95 over 360 multiplied by pi times 11 squared. Let's put that in the calculator. Oh, I have that right here. I can just change that to 95 and 11. And that's going to be 100.31. We'll cut that off after the 1. 100.31. All right, next question. In this circle below, what is the area of the unshaded portion? So the last question also asked for a shaded portion. The question before was an unshaded portion. This case, though, it's a little bit different. If you look at the image, click on it, make it a little bit bigger. The unshaded portion does not have a degree tied to it, okay? So what we're looking for on this problem is we're looking for the angle over here. And this is a full circle. So the unknown angle is going to be 360 minus the 60 degrees. So it's actually going to be 300 degrees. So whatever this angle is, subtract from 360, that's going to be your new degree measure. That's going to help you get your unknown, your unshaded area, because we're not using the 60, that's a shaded. The 300 is the unshaded portion. So it's going to be 300 over 360 times pi, and your radius is 12. So pi times 12 squared. Now let's look at our answer choices before we actually put this in a calculator. Our answer choices have our answers in terms of pi, which means we don't actually need to type pi in the calculator. We only need to type what's around it. So we have these numbers here. Leave that pi alone and just put in 300 over 360 times 12 squared. Now, 376.99 would be if I put the pi in. But if I took the pi out, I get 120. 120 pi is 376.99. See that? Those are equivalent. Those are the same thing. But 120 pi is the exact answer without having to round. So we would put that answer for here. Next question. What is the length of the blue arc in the diagram shown below? Round to 2 decimal places. Again, I'll throw this up here. This is an arc length. We want to know the length of this arc from here to here. Well, this is a quarter of a circle. You know, if you think about this circle extending, pardon my terrible circle, but this is a quarter of a circle. This is your radius is 8.5. Your degree is 90. Everything's laid out for you. So we want to know that the length. Okay, now the length formula for degrees is going to be the degree over 360 multiplied by your circumference, which is 2 pi r. So we're actually going to plug in our 90 in for the degree. And we're going to times that by 2 pi, and then your radius is 8.5. So let's plug all that in, see what we get. You can pause the video, check it on your own. You can unpause it and check with me. 90 over 360, right arrow, 2 pi parentheses 8.5. And that area, that length is about 13.35. So 13.35 will be your answer. Round to 2 decimal places. So 8.5, 13.35 for that length. That represents, if I were to measure that length, that's how long that would be. Next question. All right, look at this question, pause it, try it on your own, unpause it, check my answer. Let's click on the image, make it bigger. What is the length of the arc in the diagram around the 2 decimal places? It's the same as the last question. All right, we got our degree. We got our radius, everything's there. All we gotta do is work it out. So degree over 360 times 2 pi r, so 2 pi times 14. Everything's there for you. 80 over 360 times 2 pi r around the 2 spots. 80 over 360, 2 pi, what was the radius? Times 14. So that's 19.547. So I would say 19.55. 19.55. So that length is 19.55. All right, next question. A circle has a circumference of 62 inches. What is the length of an arc intercepted by a central angle of 100 degrees around the 2 decimal places? So circumference. So when you do that degree over 360 times 2 pi r, please understand that 2 pi r is the circumference. That represents that. So when it says the circumference is 62, that's going to substitute the whole thing, not just it's not the radius, that's not pi or 2, it's all of the circumference. So that's going to become 62. So this equation is actually very simple. Your 100, that'll be your degree, 100 over 360, and then you're just going to multiply that by 62. 100 over 360 times 62 is going to be your answer. So that's going to be, let's see, 100 over 360, and then all that's just going to become 62. So 17.222 repeating 2 decimal places is fine, so 17.22. All right, let's move on. Next question. Okay, in this question, a circle has a diameter of 16 inches. What is the length of an arc subtended by a central angle of 3 radians? Here is where we're going to fall into our radian question. Okay, so now we're going to do our length equals the radius times the radians. So remember, this is radian. This is length. So anytime they throw out the word radian, use this formula, okay? Your length is, well, we don't know it, we want to find it. So our diameter is 16. Remember, in a circle, diameter is always going to be all the way across. So if the diameter is 16, then that radius is going to be half of that. So the radius will be 8. And then your radian is 3. So this is 8 times 3. Seems easy. We don't need a calculator for that. That's 24. So that length is going to be 24. What that means is we can wrap around in this question about 3 of these radiuses, right? 24 units. So it's almost half a circle. All right, 24. All right, last question. Let's move on. A circle with a 28-inch diameter has a central angle that intercepts an arc measuring approximately 64.24 inches. Which option describes how to determine the angle's measure in radians? Well, here's your formula again. S equals r theta. So we have a circle with a 28-inch diameter. If the diameter is 28, then the radius will be 28 divided by 2, which is 14. So I know that that's going to be 14. And I know it intercepts an arc measuring approximately 64.2 inches. That's your length. That's your S. So we're going to plug in 64.24 into that equation. So we have 64.24 equals 14 times your radian measure. So the question is, which option describes how to determine the angles measured in radians? How do we solve for that? How do we get theta? Well, we have to divide. So we're going to divide by 14. So 64 divided by 64.24 divided by 14 will give you your radian measure. So we divide 64.24 by 14 to get that answer. And you can put that in the calculator, but this question doesn't want to know what it is, it wants to know how to get it. So you divide 64.24 by 14 to get that answer. All right, thank you for doing this review. The next up is going to be chords and inscribed angles, so stick around.